So consider the ultimate AI assistant. It should be able to recognize the word around it, the world around it. So, computer vision. Using some kind of CNN to recognize objects around the world and how it's constructed. Once it recognizes it, it should also be able to understand language and sounds, the voices that people make. And once it understands that, it should be able to communicate to its owner its thoughts and actions that it has done. And this is in the domain of natural language understanding. Not only that, because humans are complicated creatures, and the machine needs to be able to communicate with humans as well. Not just doing things for humans and taking orders from humans, but also understands human needs that the owner may not necessarily be able to express with words. And sometimes we're not always capable of explaining our needs, but we show it on our face. So the computer needs to be able to get there, or a digital assistant needs to be able to get there, if we want a more powerful assistant. And that's why we had the app Womoji, because Womoji is just a component, and it lets us look into how facial expressions can be detected through computer vision. And now the obvious way to go about it is to use CNN, which we didn't use in the end. And I'll explain why we didn't use CNN in the end. But CNN, as of right now, achieves the state-of-art image recognition rates. And it beats any other models that's come before it. But when we first had this project, the supervisor wanted us to train on CNN, and the requirements is 1,000 images to train one facial expression. And we thought that's crazy, because we wanted the user to be able to provide training samples to the machine. So the machine will be able to train based on a specific user. So all its training data comes from its owner, not from somebody else's face. So it's like raising a dog or like a pet or a cat, except in this case, the machine's gonna be a lot smarter than a dog and cat, maybe even smarter than its owner. So I don't think it's realistic to expect the user to provide 1,000 images for just one facial expression, let alone however many kinds of facial expressions. That's just way too much for the user. So we want a model that's able to be trained relatively quickly and perform reasonably well with a very small training set. And this is what we call something called small data. We want to be able to use as little data as possible to get a result that's decently good. And I think that's something that you're going to find within the next couple of years. And that small data is going to be just as important as big data.